Okay, so this video is going to be about 6.4 or 6.3 in the book, which is links to exercise 6D. And it's not too difficult of a chapter. It very much just is dependent on our simultaneous equation skills and our understanding of the discriminant, of showing where lines intersect circles. We've done stuff with lines intersecting lines, straight lines intersecting polynomials, so like quadratics, cubics, etc. But it's a really important skill as well to have things with lines and circles. And basically, like I've just said, to consider when lines intersect, we first will look at kind of substitution and simultaneous equations. If you're trying to show that it doesn't intersect or has no intersections, then you won't be able to solve them simultaneously. It will be impossible. They don't have solutions. So that's where the discriminant comes in. So in your head, kind of think of the rules. If you're trying to show that it touches at 1 point or 2 points, simultaneous equations is good. If you're trying to show that it never touches, then discriminant is the way you want to go. So I've got an example of all three, and an example with some k's in there, because A-level stuff loves to throw in k's and then you find the value of, or range of values of k. So in this one we want to show that the line y equals x plus 3 never intersects the circle with equation x squared plus y squared equals 1. First of all, let's just have a look at the diagram. This isn't anything you need to do, but I actually recommend it for the question because it gets you a good understanding, and it gives you a slight way to check your answer, because you know how to plot lines quickly and you know if it makes sense or not. So if I was to plot this circle, that's a circle with the centre at the origin and a radius of root 1, which is 1. So it's going to look something like this, with minus 1 there, 1 there, 1 there, and minus 1 there. And the equation of x plus 3, well, that is going to cross my y-axis at 3, and it's going to have a gradient of 1, so it's actually going to cross this at minus 3. That's a terrible straight line. So just by drawing the diagram out quickly, we can confirm that, yeah, it makes sense that they don't intersect. Sometimes when it's saying find the 2 points of intersection, and it very clearly intersects in this quadrant where we'd expect a negative x and a positive y, let's say you don't get that, you get something like 16 minus 40, which would be down here. You could quickly say, well, my diagram doesn't agree with that, so I need to relook at my algebra. If you don't draw a diagram, you'll never realise when you've gone wrong, because you'll just put blind trust in your algebraic ability, even though you could have made a daft little error in there. But anyway, that aside, let's have a look at solving this question. So first of all, we want to substitute. We want to substitute in, so I'm going to substitute y into where it says y squared. So that's going to be x squared equals to x plus 3 squared equals to 1. And then let's rearrange. So we've got x squared plus 6x plus 9 equals to 1, and I'm going to make it equal to 0. So I've got 2x squared plus 6x plus a equals 0. I can divide all by 2 to make it a bit easier for myself. Oops, that's not meant to be there. And because I'm trying to make it show that it never intersects, I'm going to use my discriminant, and my rules of the discriminant, just in case we have forgotten. We use that bit of the quadratic formula that's underneath the square root, so b squared minus 4ac. If that is greater than 0, then we have two values, or two solutions I should say. If b squared minus 4ac equals to 0, then we've got one solution, and then the one we're after If this is less than 0, then we have no solutions, and that's true because, well, if we're trying to square root, we have square root of b squared minus 4ac. If we're trying to square root it and it's a negative number, we cannot do that unless we go into imaginary numbers, which is a further maths and on topic, but it's not a proper solution. So we're trying to show that essentially. So b is 3, so 3 squared minus 4, a is 1, and c is 4. You don't need to write out on the paper what your values of a, b and c are. They just assume you are doing it. If you show this line of working, it's perfectly fine. So 9 minus 16, that equals to minus 7, which is less than 0, and you say therefore no solutions. So it doesn't intersect. My bad handwriting. I haven't written anything for 2 weeks. So it doesn't intersect. And that's as much as you need to do for that question. So nothing crazy, it's just a discriminant, very basic discriminant thing that we were doing right at the start of the year. And then we've got 2 more examples here. So this one, find the points of intersection. So by the way they've worded that question, I assume that there are going to be points of intersection. I could do a very quick plot to just get in my mind, do I think that it's going to be intersect? You do need to, if they ever say something like do these intersect, you do need to show it algebraically. A diagram roughly sketched won't be enough. If you meticulously find all points and plot it that way, it would be, but it's quicker to do the algebra. So this isn't anything to get marks for. This is just some good mathematical practice. If I plot the circle, that's going to have a centre of 0, 3, so up here. And it's going to have a radius of root 29, which is just under 6. Yeah, 5.4, my calculator's saying roughly. So that's going to go up to like 8. From here, 8.4, and it's going to go down to minus 2. So and it'll be minus, that's terrible. But again, this is why a sketch is never a definitive proof, because they are more often than not dreadful sketches. And then this is the line y equals x plus 6. So if this was 3, this was 8 point something, 6 is going to be there. It's got a gradient of 1, so it's going to go like this. Pretty clearly, I am going to have 2 points of intersection here. My sketch was awful, but it was good enough to show and confirm in my head that I am going to have 2 points of intersection here, just because that 6 is going to be between these 2 points. So let's just go ahead and show what they are. First we're going to do substitution. I'm going to put y into here. So that's going to be x squared plus brackets, that's x plus 6 minus 3 squared equals to 29. So x squared plus, that would be x plus 3 squared equals 29. So x squared plus 6x plus 9 equals to 29, and I'm going to rearrange this to equal 0. So 2x squared plus 6x. If I take away 29 from this side, that's going to get me minus 20. Well, why don't I divide by 2? To make it easier for myself. Pray this factorizes nicely, otherwise you're going to have to do the quadratic formula. This does factorize nicely. We have positive 5 and minus 2. So therefore x equals minus 5, or x equals positive 2. Let's go back to find my y values by substituting it back into the nice and easy one. So if x is minus 5, then y equals to 1. And if x equals to 2, then y equals to 8. So my coordinates of intersection are minus 5, 1, and 2, 8. Decent amount of algebra in there. nothing too hard. We've done so much of this throughout the year of substituting in and solving simultaneous equations with some quadratics. Hopefully nothing that scares you at this stage, but if it does, then let me know, and it's something that is worth getting really, really secure at, because you'll see it constantly. Okay, and then this one. I said that if we are showing that it has any points of intersection, 1 or 2, that algebraic methods like what I've done on the left would be best. But the problem with this is we have this value of k in one of the equations, which makes it so we have 3 unknowns, which makes it impossible to solve. Unless we wanted to solve it in terms of k, then we could. So because of that reason, we are going to go back to our value of the discriminant for these ones where we have a third unknown in there. And the reason for that is, if I go back a slide, when we get to this stage here and we do the discriminant, we actually get rid of the values of x. So then we lose an unknown. When we do the discriminant in this next question, we'll keep the value of k, but we will lose all the other. We'll have substituted out y to get rid of that. We'll have done the discriminant, that would have got rid of the value of x, or the letter x, and then we would still have k in there, but then we can solve that, because we'll have an inequality to solve that we'll set up through our 3 discriminant things here. So that's why we're going to do that. And again, this is a skill you see a lot in A-level. This is why I kind of like this chapter of circles, because it links in pretty much everything. It's really good. So first of all, we need to do some substitution. And I'm going to substitute y into where it says y squared. So x squared plus x plus k squared equals 1. When I expand that, I'm going to get, that's going to be xk, so 2xk. So I've got 2x squared plus 2xk plus k squared minus 1 equals 0. Don't need to divide by 2 here, I don't think, because we'll end up with some fractions of k squared over there, which is going to be more awkward than it's worth. So I would keep it as 2x squared here. I think it'd be easier that way. But if you did divide by 2, it doesn't matter. Problem we got here is it doesn't tell us explicitly how many solutions we are looking at. And we know whether we're going to set it to greater than 0, equals 0, or less than 0 for our discriminant. We need to know. The fact that it says touches, and it's not always going to be put in bold, but I've put it in bold just to really, hopefully you saw your eyes on that and you were thinking, when am I going to mention it? When it says touches, that means just at one point. It's like a bit of a, in mechanics when we had them unwritten rules in the Suvat equations under gravity. This is one in terms of algebra. It's like an unwritten thing. When it says touches, it means it just hits at one point. So if we was to have my circle over there, this would go and it would touch and then it would leave. It would be a tangent to it, if you remember that definition of tangent. So that's what we're going for. We are going for one point of intersection. So therefore b squared minus 4ac equals 0. We're going to find a definitive value of k because it's equal to 0. If we were trying to show that it had no points of intersection or 2 points of intersection, we'd have an inequality, and the question would ask, instead of saying find the value of k, it would say find the range of k. And all that means is do the same thing as I'm doing here, but instead of getting like k equals 2, you might get k is less than 2, or k is bigger than 2. Or you might get something more complicated where it's between 2 values. But just because they ask you for a range doesn't mean you are doing anything fancier than what I'm doing on the screen right now. You just have an inequality, and that's why you get a range. So let's just go ahead at this. The value of b is 2k. I should have really written it like that, shouldn't I? 2kx. So 2k all squared. Remember, it's not just 2k squared, it's 2k all squared. So don't fall upon that. 4 times by a, which is 2. And c, notice how I put brackets around this, because that is the whole value of c. K squared minus 1 is c. Not just k squared or not just minus 1, it's all of that. And that equals to 0. So when I expand this, again, this isn't just turning into 2k squared, you've got to square all of it, so it's 4k squared. That's 8k squared. Don't trip up on this as well, there's a lot to trip up on this in terms of algebra. This is minus 8 times by k squared, so minus 8k squared, minus 8 times by minus 1, so that's positive 8. There's two things that people could trip up on there. Having that as a 2, having that as a negative number. Very, very careful on that. So let's solve this. We've got minus 4k squared plus 8 equals to 0. Well, we can just take my 4k squared to the other side. So I have 4k squared equals 8. Let's divide by 4, so we get k squared equals to 2. And we're going to get k equals to plus or minus 2. Let's see if we need to pick either of them values. Use an algebraic and not geometric, so don't just draw a picture. Determine the k such that y equals x plus k touches. My circle would look like, again, just a diagram just to confirm which one we want. My circle would be centered around the origin. If I had a equation that was x plus positive root 2, it would start up here and it would come down. It would, that in my mind, I think yes, that would touch. If I had x plus minus root k, well, it would be down here, and it would. Yeah, I think both of these would be valid. So I think we could have two possible values of k here. So I think k could be positive or negative root 2. We can always go on you can always get yourself on Desmos and plot that, just to double check if you believe both of them, and I'll be checking myself afterwards. But we got ourselves down to a value of k, and we can stop there. Okay, so not all the questions from 6D, but I'll post a question list on Show My Homework for you. Sorry if this one was a little bit longer, but anyway, cheers.